And this is...
You can start with Lloyd.
All right. Thank you, everyone. And thank you, Rashni. And my name is Louay Al-Jondi, and I'm excited to be part of these webinars. And I hope the information that we will present here will be helpful and useful for the audience. So welcome to the webinar. Let's start by introducing myself. I have more than 20 years in QA and software development experience. I'm currently work for Microsoft as a senior QA manager. Philosophy of my QA approach is quality is priority number one. There's no cutting corner. When we manage the QA team, this is what we promote this culture. QA team can be involved as early as possible in the development, so they can add value since they have the customer vision of the functionality of the product. When it comes to automation, your automation is as good as your test cases. It doesn't matter how sophisticated your automation, if it doesn't serve your goal to have good quality of your product, it's not going to help you. Could be a waste of time. So automation is a mean to achieve your quality goals, but not the goal. So put this in mind from my experience perspective. Now, the automation team and the quality team can make the complex automation simple to use by anyone. And as well, continuous improvement as you go, because nothing is static in the development software cycles. Everything is changing by sometimes a week or a month. You get a new library. So continuous improvement is the key to success to your automation. This is the philosophy I'm using in my QA work. Now, the QA team should focus from customer perspective in building the correct software that is useful. From development perspective, doesn't matter if you build the best feature ever, but it's not usable by a customer, it's not worth it. It's not worth the investment or the work. So the right product in the upper right corner here will show you that this is what we seek when we build software. And the quality team should be part of the decision because they know the history, the feature, the functionalities from high-level perspective more than the unit-based perspective. So the quality team has a role to play here during the development. So the automation focus is automate all test cases, or most of them. We know some test cases are hard to automate, so we leave them as a priority number two, but we focus on the speed, the automation because of the speed of testing. The second one, improve the quality of your automation. It's a software automation application is the software. It has to have the same high quality that you seek when you test your software. From code quality, from test, from reporting, from stability, etc. So this also, this should be one of the focus when you start working on automation. And at the end, keep improving your infrastructure. Everything is moving in software. Keep your eye on your automation and keep improving it. It's very important. And move from one area of functionality to better area or more high, the next level of framework. For example, if you have a current test using some tools, but you know the spec flow BDD is going to help you more and make your test more clear and more cooperative environment, you can move to the spec flow BDD. So why the need for continuous testing? This is very important in agile environment that you need quick feedback on your feature development and you need to have a package that you can repeat your test anytime you want, and you trust it from results perspective. It's reliable, and you can reuse it whenever you want. So this is the key to have good framework and good automation, and it helps you to do continuous testing in your environment. So the automation strategy is important, and nothing comes without thinking and planning in advance. The automation strategy is to answer some questions that you put before you start writing strategy. What do we need to do, and why? You need to have enough reason to share with stakeholders that I need to invest this because of that. Once you answer the question of what and why in your test strategy, you move to how. How is doesn't come first. Should be the third items on your question. What kind of automation? What kind of language? What kind of framework? This is when how. And then who's gonna do it? Do I have the right team to start this kind of automation? And then when I need to start, when can we run it? What's the frequency, etc., etc. Usually using OKRs in your strategy will help you put a vision in every period of time, usually every quarter, that this is what I need to do, and this is what my plan for this test strategy and automation. And don't delay this process thinking. Just you can get started, especially if you have a new project. I've been involved in a new project that has 0 line of code, and I've been involved in a mature product that has been under development for 10 years. So each one is situational. If it's new product, maybe much easier to start. Even if you start on the wrong direction, you can fix it later quickly, but it's good to start. Now, when it comes to automation, it's important to measure the benefit and the cost of your action. So this diagram will give you a little direction about evaluating the automation and the cost of automation. If you have high benefit and low cost of automation, this is where you start in the green. If there's low benefit and low cost, maybe limited coverage, you put it the second priority. If the benefit is high, but the cost is high, writing very complex framework for your environment, maybe it's worth it. And then you mitigate the risk with sufficient coverage. How much I need to do? What the percentage when it's high benefit and high cost? And then you have the low benefit and high cost, like writing automation for UI, for example, that you don't need it. The UI is not the focus of your test. So why you need to invest here? It's really costly, and the benefit is you can replace it with other alternative of testing rather than automation. Once you do this analysis in your test strategy, you can make the sound decision where to go and how to start. Now, one of the good techniques to use when designing automation is the quadrants. This diagram created by Brian Merck a few years ago, and it's really helped the people who are using it know the benefit of it. I used it myself in several occasions, and the test cycle, the development cycle is divided into 4 quadrants. When you start your work on any feature or any piece of product, the Q1, the quadrant 1, where you need to pay attention to unit tests. And this is automated. Unit test is part of automation, and usually done by development team. And this is where the biggest return on your testing is here, the quickest feedback. The Q1, they call it technology facing that support the team. So you are working purely in the technical term, but you need to move on as a team with your features. You cannot wait to finish testing and then to finish development and then testing. So this is where you have a quick return on your work, and you know what you're doing with your test. The second area of where to have automation focus is Q2. This is to support the team with business facing. So functional tests is a business facing, and it supports the team as well. And other area like the story tests, the prototype, simulations, all done in the Q2, and all can be automated to make a quick return on your work. How am I doing? What's the features doing, and how the integration of all features handle the testing. And then in Q3, which is non-advisable to have any automation in this area, it's business facing that critique the product, and this is usually evaluate the quality of the product from users' perspective and provide feedback to the stakeholders. They include usability and exploratory testing. This feedback is important, and something is missing in Q2 can be found in Q3. Feedback will be sent to the team to fix it, etc. This is how it works. In Q4, which is technology facing that critique the product, this includes performance and security and or other utility that we call it tests like usability, maintainability, scalability, all this kind of testing. It happened in Q4. And this will expose the potential risks and flaws of the product and challenge its design and architecture. So critique, it doesn't have the negative sounds here. The critique is evaluate the product against the requirement, but make sure everything is working. It's put it under performance, doesn't crash, doesn't leak memory, doesn't do any bad things when you do it. Also, security is important. Any security defect is blocking defect. It has to be fixed. This is very important. The security problem comes from any direction, third party you're using in your software or your code itself. It has security flaws in it. So Q4 is important. This is how you make sure your cycle is development cycle is sound and it's working as and the quality is maintained as high as it can be. But the point here is where to automate, where to focus your automation. It's Q1, Q2, and part of it in Q3, especially when it comes to performance. Now, once you start writing automation and building framework for your automation, you measure it. How to improve it? You cannot improve if you can measure it. And there's an example how to measure it is, for example, a framework. You give it a point or star, and you fill the gap that you need in each phase. When you start writing your automation, I think your framework would be in maturity level 1. It has a lot of ad hoc or manual work. It's uncontrolled. If you move to the reactive phase, for example, it's individual driven. People can drive the test from framework, but require some manual intervention. So you know what to improve here. When you are proactive, you have sophisticated framework, you have tool integration and good reporting. You are proactive, doesn't need a lot of manual intervention. But when everything is automated, which is, I usually call it automate the automation. Now you have everything managed, and you give it 4-star, and all you need is to do continuous improvement. No need for human intervention when you run the test. This can be happen during the CI/CD in the pipeline when everything is done flawlessly without problem. Now we move to unit test. What's the advantage? As I said in the quadrant I mentioned, it's usually very fast, very specific. Test the unit exactly, doesn't go beyond that. It's portable to any other area. People can use it. It should run in isolation. You don't need to connect to server or external component to run your test. You can unplug your internet and run it. This is how it should work. And this will give you a quick find of your defects. If there's defect in your code, you can find it faster. And it's the advantage, you can tell your code coverage. How much testing do you have coverage in your code? This is very important information, and this is the advantage of test-driven, the unit test. Now, when it comes to test-driven development, the initial test is written before starting code, and this is a cycle. You write test, you code, and you improve your design. This is very tricky process and requires some skills and cooperation, and I don't think a lot of teams are using it, but it's good to promote this culture, especially with the development team. This is from unit test perspective. Some tools are used to measure the code coverage. For example, the Sonar Cube is one of the tools that help team get quick feedback about their coverage. You can use it in your feature branch, and it's used every day in your master branch or main branch. And it runs daily every time you submit any changes or new feature. It runs and gives you quick information about defects, code coverage, the status of your code quality, and how to make a decision to fix any problem. You can be proactive and use, for example, SonarLint to evaluate your code coverage before even submit your change. Any defect reported by the tool can be triaged and solved, either solved or deferred, depending on the criticality. So what is BDD? Moving to functional test, which is the focus of QA team, we're promoting BDD all over the places here where I work. So BDD is a set of software engineering practices designed to help teams build and deliver more valuable, higher quality software. This is what we are aiming for, to do high quality everything. This is our goal. We need higher quality product, and this is how the customer like to use our product as quality. Buggy product is problematic from business perspective, and customer confidence of the product and the company and the business in general. So BDD originated from the TDD earlier. This is the early inception of BDD. So it has a lot of good advantages, but still many teams still have difficulty adapting to it. And I see resistance from especially people who work in development, that they see it's maybe a waste of time. We can jump into writing code test in NUnit directly, functional test, rather than working with BDD. BDD focus on the code from business perspective, from business term. This is the feature, and this is how it's going to be used by customers. And BDD the behavior-driven development. BDD will tell you exactly, will help you figure out this. And it's every time you write, you discover maybe it's not the feature that it's going to be used by end users. So you can change requirement, and as an agile good practice, things are changing. So requirements will evolve eventually if you see something not doesn't make sense from customer perspective. We use with BDD, as some people maybe know, familiar with Gherkin language to write your behavior of any feature of any test case using BDD. So BDD can be done with test-driven development. So we can write feature file before even the code is ready and automate this feature file and run the feature file before you have code. And you discover it's failing in the beginning because there's no code from the feature perspective. And you work with the development team, or if the QA and development team in some areas are mixed, that are the same. So cooperation between whoever writing the feature and whoever writing the code can cooperate and run the test beside unit test, the BDD as functional test. You run it until the test is passing. It means the code is complete. And the automation here is crucial from BDD perspective. Non-QA should be able to write automation because you write the feature test in the editor in pure language, English language, and you write the code later on. But anyone can write this feature file from the team, from the QA team and development team, even if they're not involved in writing automation. So BDD unit test with .NET environment, we use SpecFlow, and SpecFlow has a story that in the last 2 years they didn't release any new SpecFlow releases. So the replacement, we call it rack and roll. It's the evolution, as I said. This is what continuous improvement. The rack and roll claim, I haven't used it yet, but I read a lot about it. It's going to replace SpecFlow and support everything SpecFlow support now, plus the new libraries like .NET 8 and newer. So SpecFlow has a feature file called the editor, and you write your scenario in it in Gherkin language. Use Gherkin as guidance to write your automation scripts. The advantage, you write maintainable test. It's easy to read and it is easy to change, and you can maintain it even if you don't understand what's behind it in C#. It's good for communication and collaboration between teams. Clear traceability. It's one editor. You see the feature, you see the test cases. No need to write something in Confluence or spreadsheet or any other type of editor beside this. So it's one-stop shop. You can use it. And this is good thing to engineer in your automation framework to use this process. BDD SpecFlow integrate with IDE like Visual Studio, which is the most famous IDE in the market now from Microsoft, and we can integrate it in the pipeline. This execution is faster when in the pipeline. You don't have to copy, like I used in the past, JMeter, for example. You need to copy JMeter with all the script to the VM in the pipeline, and this will take time. It's more expensive to run it than the BDD in Visual Studio. Visual Studio, it's there. The scripts are there. You don't need to have anything else. You run it. It's faster. it uses less agents or VM in your test. And this is another saving. So the time, the VM, and the quick turnaround is very important. One of the great advantage of using the BDD. This is an example of a feature file. As you see, you give it a name. What are you going to do? And you put the story as a user. I need to do this because of this, so I can verify something. And this is the Gherkin language. You write them in plain English in this I language to make it personal. I want to do this, navigate, I insert the text, and as you see here, text pass as parameter that takes value from this table here. You can add as many iteration as you want. Then you receive a message that tells you I'm successfully added the user or the person here. Then I receive a message to confirm and close the browser. This is an example, as you see, writing a test case in plain English like this. It's very clear to people involved in the project, whether development, QA, or even product management. A product owner, managers can read it and have an idea. Spec flow in Visual Studio organized as the following. This is how you build your framework. You create a project, spec flow project, test, and underneath it, you see the feature folder. Now, you need to create other helper projects in C#, like this one, Server Connect Client, for example, BDD test helper client. This spec flow project, because you need to add the extension spec flow to your Visual Studio, and you can create a project for spec flow. Now you divide your feature into sub features and give it descriptive name, like changing password, for example, dynamic input, focus, hosted client. So it's good to have best practices to use descriptive names. Name like feature 1, feature 2 is really confusing name, and it's not going to help you in the long run to review and adjust this. So I use those as bad example. And then the step definition is where your C# code that support the feature file live. There's a binding between the feature file and the C# code that really execute those lines. Each line has a definition that you go to C# and evaluate it. And this is the C#. It's the file is extension is .feature, and it's, as I said, it's a pure editor. You can write Gherkin language in it, and it's color coded, so you know the given. This is where you lay the ground when you start by set the condition to start your test cases. And then you do the action, you do when I launch, this is the action. The and under when has the when meaning. So we have when and 3 ands underneath it, which is 3 when. That's the action you're taking. Once you do those actions, when you click submit, then you get the expected results. This is how you set the expected result. If you compare it to the traditional way of writing test cases, where you say step 1, step 2, step 3, this is something similar, but it's more direct and much easier to write. Like if you remember Silk Central or QTP or test, where you write test cases and you end up with zillion folders and all manual, and it's hard to maintain it's much easier and more practical here to use your test cases. So as I said, this is how you do it in .NET environment. Same with Java, Cucumber. You have something similar with JUnit. And in .NET, we support NUnit, XUnit, MS Test. 3 framework can be supported. And this can do API testing and UI testing. If you do UI testing, we use Appium as an extra extension and component, and Java Node.js to run the server. You can combine it with this spec flow and add definition to all your windows under test. This is if you want to focus on the UI testing. When your product has a lot of UI that you need to test it, but it's not advisable to keep the UI high priority. Test things underneath the UI, all the API call first, is if the UI is crucial to make sure it needs to be tested every time you release. Now you can write a limited number of UI testing. So this can combine with spec flow here. You can add the Appium element and use it for UI-driven testing. Now, the other part I need to touch on it is the report. So about results, every time you have automation run, you get pass fail. And usually it's sometimes confusing when you see failure from automation results, but you don't know what this failure is. The best way to approach it, what I call it failure management, is to make sure to know what the failure coming from. So for example, some product, when you run it, it's using multiple component externally to the product itself. So this is a product that we know if it fails, we know there's a problem and we report the bug. But sometimes when you run the test, especially in a pipeline, with nobody is watching what's going on, sometimes the automation fail itself. Sometimes the server that support your product do some transaction fail. Sometimes the test environment, machine crash, test machine, for example. Sometimes the machine doesn't show up when it gets involved in the pipeline. Sometimes the other server, also authentication server, for example, is down. So the test case will fail for too many reasons. If you identify all the elements that can contribute to your failure, now you have clarity of why the test case failed. Now, when you have the clarity, you need to add it to your automation code. So the automation can report exactly where the failure happened. If it's product, you're done. You write a defect, you analyze it quickly, you write a defect, and you're done. But if the failure from here, the report should tell you that this failure happened because server 1 crashed for some reason, or timed out for some reason, or some transaction didn't work here, or the server 2, or the test environment the machine wasn't in stable condition. So when you have this in your report that tells you, yeah, I have 3 failures, 2 of them related to server 1. Now it's not product. You fix whatever need to be fixed here in the framework. And then your reporting dashboard should be, now if you're using Azure Pipeline, it has its own report site, and you can tell that you can identify what the failure. It's based on how sophisticated is your automation. As I said, this is the continuous improvement. You write it first time, and you can tell which one pass fail, and then you go to the analysis, the failure management analysis, and you can identify what's the reason. And you do this with the cooperation of your team and development team. What could go wrong here? And you get the automation to report this instead of you spending time to find out. So the automation should be sophisticated to do this, and this comes from continuous improvement. Every time you write something, you can tell the automation is here. If you can add to the automation process that if the server from the failure from server 1 happened, let's run the test case again to see if the first time the server wake up the second time. Now, those components important to resolve any problem with it. Don't get me wrong. You're focused on the product, but the other component that your product use must be fixed, especially the automation. If you have failure because of automation, now this is a problem. You need to fix that. This is why I said automation in the beginning. The automation should have good quality code in it. It's not anything automation. This is a very important part to notice here. As I said, your report, this is an example of Power BI report, which tells you how many test case, what feature you're running, divided by feature, everything organized. You know where the test, you have 22 tests passed, for example, 2 failures, where here you have 465 passed, 6 failure, 2 of them based on other failure. And you can in Power BI, based on how you write the result, you can drill through and figure out what's the failure originated from. Is it timeout? Is it from some server? Is it from the back end? Is it script error? Everything should be isolated and defined in your automation script. And this is how you can build the right automation for your test. So now this is the end, and I hope the information was useful to you, and I welcome any question later on from the audience. Thank you very much. Roshni, back to you.
Thank you so much, Roy. Just give me 1 second. I will share my screen from here.